Conventional techniques. So, risk adjusted discount rate is one of the conventional techniques. In general, the discount rates in capital budgeting represents the expected rate of return because we are expecting those returns. But in such returns, how much portion is risk free and how much portion is involved risk? We don't know that. And if we compare with the statistical techniques, what those techniques are suggesting, if project has high risk involvement, don't consider the project, and it is not preferable according to that statistical techniques. But in conventional techniques, what these techniques are suggesting, consider the project, how much is risk free and how much is additional risk element involved. So let us go with this risk adjusted discount rate. Projects with higher risks are generally expected to provide higher returns, and projects with relatively lower risk are expected to provide a lower rate of return. If we don't take the risk, we don't get the higher return. Consequently, all projects should not be discounted at the same rate, namely the company's cost of capital. All projects should not be discounted at the cost of capital. Hence, the cutoff discount rate should be adjusted upward or downward to take care of the additional risk element. This is referred as a risk adjusted discount rate. So how to compute this? Okay, before going to the computation part, let me explain one more point here. So in capital budgeting decisions, we have a opportunity cost element. In the sense, we have two proposals. In those two proposals, which one should preferable? And if we consider the risk element here, if we invest in a post office bonds, those are risk free and those generate lower rate of return. If we invest in a share market, we'll get higher returns because the risk element is higher in those investment proposals. Likewise, what this technique is suggesting, whatever the risk free rate, just consider those risk free and take care of the additional risk element. In the sense, mention the risk premium rate. So whatever the risk element is involved, mention it. Likewise, this technique is suggesting. So how to compute this NPV under risk adjusted discount rate approach? So first one, identify the cash flows. Second one, compute risk adjusted discount rate, that is cost of capital plus premium for risk. Third one, discount the cash flows at risk adjusted discount rate and find out NPV. So don't be confused with the risk adjusted discount rate. Okay, it is as simple as considering the cost of capital. But the thing is, we have to add some amount, some percentage as a risk premium to the cost of capital. So decision rule: if project yields a positive NPV, it can be accepted, otherwise rejected. So let us go with the illustration. An enterprise is investing rupees 100 lakh in a project. Risk-free rate of return is 7%. Risk premium expected by the management is 7%. The life of the project is 5 years. Cash flows estimated as follows. So 5 years and respective cash flows in lakhs. Calculate the net present value of the project based on the risk-free rate and also on the basis of risk-adjusted discount rate. So calculation of NPV at risk-free rate, that is 7%. Now, so this is the table to calculate the NPV at risk-free rate. So years and cash flows, present value factor at 7%. So 0.935, 0.873, 0.816, 0.763 and 0.713. So present value of cash flows, we have to multiply the cash flows with the PV factor. So we'll get the present value of cash flows. So total present value of total cash inflows is 244.34 lakhs less PV of outflows, less PV of outflows, that is 100 lakhs. See here, PV of outflows 100 lakhs. So that NPV is 144. Therefore, NPV is 144. So second one, okay, calculate the net present value of project based on the risk-free rate and also on the basis of risk-adjusted rate. So what is the risk-adjusted rate? So cost of capital plus premium for risk. So risk-adjusted rate is nothing but risk-free rate plus risk premium. That is 7% plus 7%, it is equal to 14%. Calculation of net present value at risk adjusted rate. So I'm taking the same table. Okay, but at 14% we have to consider the present value factors. So PV factor at 14%, 0.877, 0.769, 0.675, 0.592 and 0.519. We have to multiply with the cash flows. Then we will get the present value of cash flows and PV of cash inflows. Total PV of cash inflows are 199.80. So PV of outflows are 100. So net present value is 99.80. This is how we have to calculate the risk adjusted rate. Let us solve another illustration. Determine the risk adjusted net present value of the following projects. So this is also very easiest one. So first of all, we have to determine the risk adjusted rate of return on the basis of coefficient variation. See, statement showing the risk adjusted rate of return on the basis of coefficient variation. Okay, so projects XYZ and coefficient variation. Coefficient of variation. So for project X, it is 1.2. For project Y, 0.8. Project Z, 0.4. So next, risk adjusted rate of return. Risk adjusted rate of return. So here the company selects the risk adjusted rate of discount on the basis of coefficient variation. See, this is the table where the link provided coefficient variation 1.2. Here we have to see the 1.2 and then pick this percentage 16 percentage. So it is already given risk adjusted rate of return, that is 16 percentage. So at 1.2 risk adjusted rate is 16 percentage. At 0.8 risk adjusted rate is 14 percentage. At 0.4 risk adjusted rate is 12 percentage. Okay, so PV factor, PV of annuity factor of respective risk adjusted rate of return. So at 16 percentage, see, PV factor is 3.274. At 14 percentage, 3.433. At 12 percentage, 3.605. Okay, done. Risk adjusted rate. We found the risk adjusted rate of return. Now we have to calculate the NPV. Okay. Determine the risk adjusted net present value. Okay. Now we have to calculate the net present value. Computation of risk adjusted net present value. Okay. So I am using another table. Computation of risk adjusted net present value projects. So cash flows. Cash flows. Cash flows are annual cash inflows 70,000, 42,000 and 30,000. 70,000, 42,000 and 30,000. So risk adjusted rate PV of risk adjusted rate factor. So for X 3.274, these are the rates we have to consider. Then we have to convert these cash flows into present value of cash flows. I just changed the name. Present value of risk adjusted cash inflows. So we have to multiply the 70,000 with the 3.274 and others respectively, so that we will get the PV of cash inflows. So formula for the NPV is PV of inflows minus PV of outflows. So PV of outflows. PV of outflows. How much is the outflow? 2,10,000, 1,20,000 and 1 lakh. PV of outflows. Now finally risk adjusted NPV. Risk adjusted NPV, that is 19,000, 180, 24,186 and 8,150. So this illustration is also very simple. Only the thing is we have to find the link, coefficient variation.